Hi folks, welcome back. I hope you're all doing well. So I want to look at this paper that was published a decade ago, back in 2014. It's called Call by Meaning, and the authors are trying to ask a very fundamental question in this paper, which is that how do you construct software out of existing components? Obviously, you construct software by composing components or libraries and then making something larger and more complex out of it. The question is, how do you find those components? The reason this paper is interesting is that once we go through the methods and vision presented in this paper, you'll see how current LLM technology, especially with tool calling, enables this vision in a much more scalable and lower barrier way. So the fundamental problem in composing with components is, as the authors put it, the lack of semantic understanding of those components. And what they mean by that is that you need to understand the functionality and the inputs and outputs of those components in a declarative way. So you should be able to find components by the functionality that they offer, rather than the current way, which is you name a specific library. You have to know which library or which component you're using, and then discover the appropriate APIs within that component. And then also, once you've found the call within a component, you have to then maybe change the data going in and out of that call, because it might not accept data in the exact same format that you have, or return it in the same format that you need. And all these steps in current software development are done manually. But the authors are saying that you should be able to do this declaratively at runtime. And how does this currently happen? Today, we find libraries by name. We manually write code to adapt inputs and outputs to the exact format that the libraries we are using expect them to be in. And the authors want to move to a world where all this happens at runtime. The vision is to have component discovery by meaning or by description. As they say, I should be able to find components by their functionality rather than by name, and then find the specific API, and then also be able to adapt the parameters and return values of that API. And here's how they are envisioning this will work. You have producers annotate in English language what their function does. So for example, if you are exporting a clock library, you would write in English language what this library does and in what format it returns the time. And then at runtime, you could ask your component library, I need something to look up the time, and it would understand all these descriptions and find you the right library for that. And mechanistically, the way you would implement it is you'd have this huge common sense knowledge base and a theorem prover that would chase a chain of implications. It would do some kind of reasoning over that knowledge base to find you the right library. Now, if you've played with LLMs and written some code that does tool calling or function calling with LLMs, it should be more or less obvious to you that this is exactly what function calling or tool calling does. The way you tell an LLM what functions it has at its disposal is by giving it a natural language description of your functions and specifying the inputs and outputs. And then the finding of the right tool or the right function happens via some sort of reasoning that the LLM does. And it's doing some sort of natural language understanding of the description of the functions and trying to match them up with some chain of thought or user prompt. And so I found it interesting that this kind of vision of call by meaning was proposed a decade ago. What the authors propose in this paper is a bit of a heavy-handed implementation in that they require this kind of database that has world knowledge, and then you have a theorem prover over that database to do some kind of reasoning. But this entire pattern, this entire goal of call by meaning is now much more easily achieved by LLMs and tool calling. The difference is that we're currently thinking of function calling or tool calling as auxiliary functionality that you use when building with LLMs, whereas the authors in this paper are thinking of it as the fundamental mechanism by which you compose libraries and components into more complex software. But then there's no reason why you wouldn't be able to use tool calling in the same way. So this would be a more ambitious interpretation of tool calling. I hope you enjoyed that. If you like content like this, please like the video, consider subscribing, and I will see you next time. Thank you very much.